We need you to be able to do this today in order to be successful in today's lesson. So we got to make sure we're good. Okay. Which triangle, you only have two to pick from, is the root 3 on? That should be my first question, right? Gabe? No. Answer the question. You guys got to get better at listening to the question that's asked and reading the question that's asked and answering it. Because I can tell you, I marked your exponential test yesterday. A lot of you didn't read the question. Right? So, anyway, we'll talk about that later. Okay? So, again, I'll ask the question again. Which triangle of the two does the root 3, is the root 3 found on? Owen.
60 degree.
The 30, 60, 90 one. Okay, so that's the one I'm going to draw on my picture here for this first question, the sine of A. I'm interested in all possible values of A, angle A, that fall from 0 to 360, such that the trig ratio is root 3, basically root 3 over 1. So what I'm going to do is I'm going to draw my picture. And then I need to figure out where is the sine of A root 3. Oh, sure. And actually, as I sit to think about this, that might be a tough one to do. Let's draw the 30, 60, 90. We might have to change this question for a sec. Oops. Okay. So if this is 30, where's the root 3? Actually, let's make it the 60. Where's the root 3? Gabe?
The root 3 is the opposite.
Mm-hmm.
The hypotenuse is 1.
This would be 1. And what's up here?
2, but then it would have to be, for it to actually the sine A equals square root 3, that doesn't work because you're doing opposite over hypotenuse. It would have to be tangent.
What would it have to be?
It would have to be, no way, because it's adjacent over opposite. No, never mind. It would have to be tan 60 to be, to make it actually tan A equals square root 3 properly.
So I think in the typesetting of this question, I forgot to put the divide by 2. So put that on the question. So right off the bat, I can see here, and you tell me if I'm right or wrong. If I were to find the sine of 60, right, is equal to root 3 by 2. Does everyone agree? Okay. So one of my angles, if I were to draw a triangle here, or I'll draw it in red. Right? The hypotenuse, you're just drawing whatever's in the like whatever the ratio tells you to draw, and the corresponding trig ratio, you draw it. So if this is 2, that's root 3 because it's opposite over hypotenuse. And subsequently, I know that this has to be 60 degrees here because 60 goes opposite that root 3. Is everyone following so far? So that's one possibility. What I said, or the question asked, from 0 to 360. So can I create, or is there another spot from 0 to 360 where I can create root 3 by 2? And more specifically, positive root 3 by 2. Robbie?
The bottom left quadrant.
Is it the bottom left?
Sorry, bottom top left quadrant.
Top left quadrant. So if I draw over here, is it not true that it's positive root 3 there and 2 as the hypotenuse? What makes it this angle then? Also 60. So what are my two values of theta? Or angle A, I suppose, right? As they've written it. There's two answers for these questions. One of them, angle A can be 60 degrees. That's the easy one. What else? Gabe?
One angle A can be 120.
Angle A can also be 120. Okay, what you need to do, look at the side lengths, or the ratio, not side lengths, the ratio. Figure out which triangle you're going to draw. And, like in the next question, you're looking at, from yesterday, I'll just reference yesterday. You're looking for the cosine of A, where the cosine is positive. Is it not true there are two spots on 0 to 360 where the cosine is positive? So therefore you have two angles. You just have to figure out what those are. Okay, and what we're going to do is use our cast rule to identify in which quadrants cosine is positive in. Right, so let's do that. We'll do the next one. Which triangle am I drawing if I have 1/2 as a ratio? You only have two options. Ever. If the ratio is 1/2, which triangle is it? Owen?
45 triangle.
Say that again?
45 degrees.
Is it the 45?
Well, since it's cosine, it can't be 60. It can be 60. Because it's over 2. It can.
It can't be 45 because I don't see a root 2 anywhere.
I thought root 2 was a hypotenuse. So it can't be.
Right, so this is, can everyone see the challenge of this? Let's keeping these triangles straight in your head. I don't see a root 2, so I know it's not the 45-degree triangle. Yeah.
60.
It's a 60, 30, 60, 90, or some derivation of it. So I'm looking for in which quadrants is the cosine positive. That'd be maybe my next step. Because it's positive 1/2. So where's cosine positive? Oh, what? All right, Dylan.
Top right and bottom right.
So in the all quadrant and in the cosine quadrant. Which means I'm just going to draw two triangles in here and try to put the information on. I'll zoom in too. They should be the same. But. Okay, so cosine says what? This is my theta, or angle A, I suppose, right? This is theta, that's theta. And it says the cosine is 1/2. So what does that mean my side lengths have to be? What is cosine? Done.
The opposite would be 1 and the hypotenuse would be 2.
Did you say the opposite is 1?
Adjacent.
Adjacent side length. The adjacent side length is 1 and the hypotenuse is 2. Which makes this in here 1. What makes this side length?
Square root 3.
Square root 3. What goes opposite the square root 3? We've already said it's a 30, 60, 90 triangle. It's not the 90 that goes opposite, obviously. So it's you're either 30 degrees or you're 60 degrees. Which one is it? Gabe, it's 60 because the smallest side length goes opposite the 30 degrees. The opposite, like opposite of 30 is going to be that side length 1 because 1's the smallest side length in that triangle. Right? And so that must make theta 60 degrees. So one of your angles, angle A. What's the other one though? I need to get from here all the way around. 300. Are we seeing what we're doing? This is not easy, I'll give you that. But there is a little bit of a process there, and I think the questions I keep asking you are the questions that you need to ask yourself when you go through this question. First question is, which triangle is it? 45 or the 30, 60, 90? Next question is, where is the trig ratio in question, positive or negative? Which quadrants? Draw yourself a triangle. Then put the side lengths on. Okay, let's do one more. A tan of -1. Where's tangent negative? If I were to draw a little grid. Remember yesterday we learned C, A, S, and T. So where is tangent negative, Bryce?
S and C.
Mm-hmm. Now, how can I get a trig ratio of -1? Which triangle would that come from? Keep in mind, I can always divide something by 1, right? Which one is that?
45.
So 45. Right? So if I drew -1 over 1, right? This can be a 45. That's what corresponds. I know these side lengths are -1, 1, and √2. So then I can figure out what are the angles. One of them is what? Remember, this is 0. If I'm measuring from 0 to here, what is that measurement? The red measurement, reflex angle. Allie? It would be 135. And if, here, I'll do the other one in like, I don't know, orange, I guess, again. What's that orange reflex angle? Hey? 315. It'd be 360 minus the 45, right? To get to that terminal arm. So it'd be 315. Those are your two possible answers. We see the line of questions I'm asking myself as I go through here. We'll do some more practice today. This lesson today is a little bit, we'll do some more. Okay, we didn't explicitly talk about that yesterday, but it is the triangles, right? Do you want to do these ones too? Are there any questions from 2 that you need to see? D? Oh, tan of 90 is tricky, actually. Okay. Do you remember yesterday? We wrote down Were you not the one to ask about this question? Okay. Let's maybe pay attention to the answer then. Alright. Tan of 90. Do you remember yesterday we said tan was sine over cosine? And we showed why? This is a rise over run, right? Does anybody know what the sine of 90 is?
1.
Mm-hmm. What's the cos of 90? 0. So can you take the tangent of 90 if it's 1 divided by 0? No. Can't take the tan of 90. So in the next couple days, I'm going to show you something called the unit circle. But first, I want you to know these special triangles, and I'm going to show you the unit, like the unit circle. Okay, and what it does is it makes a mapping of all the trig ratios. Okay, and this will become a little bit more apparent, this particular question, when we go over that. Like how I could know that the sine of 90 and the cos of 90 are 1 and 0 respectively. It actually comes from the graph, which I'm not going to show you right now. We'll do it later. So remember, in the second unit, we're going to be actually plotting these graphs and transforming them. And I'll show you, like, the graph actually depicts why the sine of 90 is 1 and the cosine is 0. Cosine of 90 is 0. You're going to see that. Okay. Just from the graphs. Okay, is there any other questions you want to see? Do you want to do the bottom ones? B? B is the cos of 90. Same argument. Yeah, you just need to know. These are ones that you just need to know, and I'll explain them later. Okay, the cos of 90 is 0. And I'll explain how that comes to be with a few different ways. Once with the unit circle, once with the graphs. Okay? And whatever else comes up as we stumble on it. Okay? You just need to know that the cosine of 90 is... do I want to do this right now? We'll worry about this later. Okay, for right now, you just need to know that that is 0. I'm going to show you how it comes to be. Okay? Any other ones? Okay, we're going to get some more practice with these questions today. How to do these. Because we're going to start doing something, I think, fun stuff with them. But anyway, we'll see how you feel about it. Let's do one more. Pick one more from the bottom one. 3. C? Too late, buddy. Too slow. Too slow. We can do both too. I don't care. Tan of angle A. First step. Draw yourself a little sketch. You could, if you wanted to, say, you could put the cast rule on. Talk about which one is positive where. It looks like our trig ratio is positive. And the trig ratio we're talking about is tangent. So, where is tangent positive? Lenny?
Bottom left and top right.
And the bottom left and the top right. You'll notice every time I draw one of these triangles, I'm coming down to the x-axis or up to the x-axis. Okay, you never draw it to the y-axis. It's always in relation to the horizontal or that initial arm, right? That's why we call it the initial arm. So everything goes relative to it, right? So, where or which triangle uses the root 2? Again, you only have 2 options. And you should at least know. I can understand maybe I'm like being flustered by where the actual side lengths go on each triangle, but what I'm not going to have sympathy for is at least being able to tell me which triangle has what side lengths. Like, where's the root 2 and which triangle, Dylan? 45. The 45. Okay, you have to know that. And I gave you the derivation of it yesterday, right? In hopes that you were able to, like, lock that in a little bit. So this is, when you see a ratio of 1 over root 2, that's the 45-degree triangle, right? We've already identified where the triangles are. So now you've just found the 45, right? And what's nice about the 45 is it's -1, 1, and root 2. +1, 1, Sorry, it's negative as well. Right? And so now we can figure out what those angles are. So the first one, angle A is going to be 45. That's an easy one. What's the second one? Keep in mind that's 0. How do I get from here to here? Keep in mind this is 180 degrees down here. Gabe?
225 degrees?
225. Bryce?
How does it work? 'Cause isn't tan opposite over choosing?
Oh, I'm sorry. Maybe that's a poorly labeled question too. Okay, let's change it to sine. Oh, interesting. Because it would have to be... Yeah, but TOA doesn't involve the root 2, right? That's a poor question. What are we going to make that? We change the question. Change the question. If we change it to sine, Bryce, now sine's positive, right? So it would actually like reverse everything. So why don't we just make that negative? That solves our question. Saves our question. Hmm?
Oh, yeah.
Well, the one and all would be wrong too. Yeah, bad question. Bad question on my part. I'll fix that. These are not actually as easy to come up with as you think they are, nor was like to actually solve them either. Right? You got to be careful with how you actually draw the ratio, and making it negative or positive. It actually makes a big difference. You want to jump over to A or B? Sorry, that's a bad question. All right. This should be fine. This should be fine. CAST. Where's cosine negative?
Top right and bottom left.
Top right and
First
bottom
right.
left?
No, both left.
Yeah, the top and bottom left. So cosine's going to be negative in the sine quadrant, and it's going to be negative in the tangent quadrant, right? So those are where I'm going to draw my two terminal arms. Okay. And then cosine is 1 over root 2. So what's that make that triangle? Again, which of the two triangles are you going to draw? Which angle goes in the bottom? 45s, right? Again, I'm being tipped off by the fact that I have that root 2. Root 2 goes with the 45-degree triangle. Root 3 goes with the 30, 60, 90. So what are those two angles? I think this question's good. So this is 0, 180, 90, 270. So how do I get from here to there? Owen?
135.
Yeah, so one of the angles be 135. And how about the next one? It's 180 plus 45.
125.
225. 225. Is that okay? You want to do one more? Because the last one didn't work out. Not bad. Like, I think if you just, there's a series of like 3 or 4 questions when you do these. Like, you ask yourself 3 or 4 questions. You ask yourself, which triangle is it? Where's the ratio positive or negative? Draw the terminal arms. And then what angle has to go in the triangle to make that trig ratio, given which trig function has been provided to me. And there's like 3 or 4 questions you ask yourself. If you do enough of these, they're pretty straightforward. Okay, again, draw yourself a grid. Where is sine negative?
T and C.
T and C. Okay, I see a root 3. What triangle has root 3 in it? Yeah, 30, 60, 90. The 30, 60, 90 has a root 3 on it, right? And it says sine is opposite over hypotenuse, right? So I'm standing here. This has to be root 3 or negative root 3. This also has to be negative root 3. So what angle goes opposite of the root 3 side length?
45. Sorry.
60, right? The 60 is the middle angle. The root 3 is the middle side length in terms of magnitude or size, right? 30 is the smallest one. 1 is the smallest side length on that triangle. And 90 goes opposite the 2 because 90 is the biggest angle. 2 is the hypotenuse, right? So I know this has to be 60 degrees in here. So what makes that those two angles? 0 to what? 240. Yeah, the 180 plus 60 would be 240. And angle A is also going to equal 0 all the way to what? 300. So that'd be this 360 minus the 60 degrees that I just drew there, right? So 300 degrees. Is that enough of those?